start recording. I actually only have the cheap version of this, so it's going to stop after 40 minutes. At that point, we'll say, oh, well, let's have a break, and then I'll set it up for the next one. So we're going to go for like 40 minutes, and then we'll talk about, we'll have a break. Break will only be a couple minutes while I set up to do the recording of the next part. So what I'll try and do is get, I have to discuss with you the course syllabus. And then when I'm finished discussing that with you, we get to start it on the first lecture. And then we'll stop halfway through that first lecture. And yeah, that should be as far as we get today. So we'll go as far as we get for 40 minutes. Now, what I have here is a class list. So I'm going to pass that around. All right. Actually, maybe when the recording stops, I'll go through and talk to you about your names and stuff like that. So I'll try and remember who you are. Yeah. Okay, so did I start the recording? I think I did, right? Right, let's look at the course syllabus. What we're going to do in this course, you can sort of see here. And so I hope you can see that. There's the name of the course, Introduction to Computing and Problem Solving. One student here just asked me about a textbook. We don't have a textbook that we're saying you must get this textbook, but there is a recommended book, and I'll show you that in a minute. Remind me if I don't. So we have a does it say it here? Maybe it even says it here. Maybe not. All right, so there's a description of what we're going to do in the course. The emphasis on the course is this thing called computational thinking, which is basically means to approach problem solving, because the name of the course is computational thinking and problem solving, right? That's it, right? Is that the name of the course? What's the name of the course? Introduction to Computing and Problem Solving. But there is a focus on computational thinking, and the idea of computational thinking is a way of solving problems by arranging the problem in such a way that you could solve it using a computer. So it's not just for computing people. You could also solve it not using a computer, but you have arranged the problem in such a way that a computer could be useful for solving it. So it's a very good way of thinking if you happen to be wanting to do a computer course. This is, I'm losing some, yeah, let's just do it like that. So there's some information there about the where we are. So you know that, yeah, so section 21, there you go. We use only this room, I guess. Yeah, section 22, yeah, we're only in this room. So how cool is that? So I'll meet you here all the time, it looks like. That's me. That's my name. I have given you some contacts for me. There's a contact for my work email address. I have actually given you my mobile. Now, the reason I do that is because generally I've found that students like to get a WhatsApp group going for their class. So you probably will do that. And if you do that and you want to, you can invite me and I'll join your WhatsApp group. You know, maybe there's things you want to say in the WhatsApp group that you don't want me to see. That's fine. You could have 2 WhatsApp groups. I don't know. But if you wanted to have a WhatsApp group where you wanted to ask me something, then I will sort of commit to you that I will answer those things. And so, you know, in the past, I've done this with students, and, you know, I'll get a little message on WhatsApp, you know, they're having this trouble with a problem or something like that. This might be 7 or 8 o'clock at night, and I'll just answer it then. So you don't have to wait until the next day or whatever. Okay, so I'll try and do that for you. And it's better if it's a WhatsApp group, because then one person asks the question and everybody gets the answer, right? Kind of like, almost like being in class. Now the CLOs, these are the learning objectives. So when we talk about learning objectives, those are very, how you say, almost legalistic words, right? They're very serious sort of words, the learning objective, right? These are found in documents that go towards accreditation of the course. And so this is kind of like a legal document between you and me. It's what I am promising to you. And then if you meet your obligation, which you promised to me, which is to try and learn that stuff and show in your assessments that you've learned it, then you get the grade. That's how it works. So what my promise to you in this course is I will try and give you learning opportunities to learn each of these objectives. And those will be basically the same as every other class that's done here. So everybody's making that promise. So then the next table is outlining how those learning opportunities will come to you and how you will be assessed. So in other words, for this first learning opportunity, where we've got these things about historical people and stuff like that, you're going to have a lecture on that. And then after that lecture, you're going to maybe do some group work, and you're going to have, and also you'll have some questions come up about this, and this is where you'll be assessed on that. So today you're going to have a lecture on that, history of computing. And so sometime later, you might have an assignment which will test your understanding of that. You'll have some questions in the quiz might be on that. Some questions in the test and the final exam might cover that. Now, if you look at this, assignments, test, final exam, everything is going to be tested in the final exam, right? So the final exam's like we call that a comprehensive exam. So you can see there we've got 5 big learning objectives, and they are some of these learning objectives when we get to the end here, right? Practice algorithms, apply algorithms for lists, function calls. That's just going to be, we're going to have little lectures on that, but you'll be doing a lot of programming. You'll have to write programs in Python to do that. All right, so then there's 100% makes up the grade, your grade in the course. You have to get 90% to get an A, apparently. You have to get 60% to pass. So your target will be 95%, right? I assume, or 100. And hopefully you'll get something around there. I'll be honest with you, last class I taught of this, I had a lot of people didn't get up to 60%. So that was kind of sad. Now that might have been for a number of reasons, but yeah, it's not easy. It's not easy. You will have to do some work, but I will try and mark you fairly, and try and indicate if there's things that that you need to look at. So your final exam will be 30%. That will be in after the lecture's finished. It'll probably be like sitting in a room like this, but you'll be separated, right? You won't be able to sit close to each other. It'll probably be a lockdown browser sitting on a computer thing, and a bunch of multi-choice questions, some short answer questions, and then you'll have to write some computer code and maybe draw some diagrams. And that'll be 2 hours. We're only allowed to do 2-hour exams now, unless they change it between now and then. Then you're going to have 2 tests. They're going to be like 20% each, 20% of the course. So that's big. All right. The test will be 20% of the course. They're almost as big as the final. And so you'll have 2 of those. One's going to be in week 5 and one's going to be in week 10 or 11. So quite big. It's worth sort of studying for those. Those will be a lockdown browser. You won't be able to have anything to help you except sitting at your computer with a pencil and a piece of paper. The quizzes, on the other hand, we'll have a quiz every other week. So like once every 2 weeks, we'll have a quiz. The quizzes will be just sitting at your desk. You won't be able to help each other. However, it will be open book for quizzes. You'll be able to look in your computer at the work that you've done before, that type of thing. No problem there. Welcome. The assignments will be on the weeks when we don't have quizzes, tests, or tests or exams. Then we'll have assignments, and the assignments, the only thing that you'll be taking home to work on. So all the labs, we'll expect you to do labs during the lab time. So that is outlined in this document, that you have to finish the lab during the lab period, and you're not supposed to get any help, but you can ask for help from me. Yeah, okay, so there's the breakdown of how that is. Look, there's your first test, week 5. There's your second test, week 8. You see the labs coming up, labs and assignments every other week, right? Quiz, then assignment, quiz, then test, right? So we'll have something for you every week, but we won't give you a quiz and an assignment in the same week, right? But look, it seems like you do have a lab every week. So lab every week, but then quiz 1 week, assignment the next, quiz, assignment. Quizzes will be in class, open book, as I said, then you got your finals. So that's kind of it. We got a bunch of rules. So I got rules in 2 places here. There's rules here, and there's some other rules there on the home page for the course, which is a bunch of stuff that we as instructors talked about at the start of the course. We basically have to do it the same in all of the sections. So there's a lot of other instructors, and so we have to have some standardization. That's fair for you. and fair for the other students, so that when I give you an A, it means the same thing as the A that's given in the other class. We're going to try and do that. And so to get that to happen, we have to have some rules and that every class agrees upon. And so that's what we've got here, is some rules that every class agrees upon. Now, I should say there's one there that's you need to look at straight away, which is about the full administrative rights. You need to have a computer on which you can put some computer software that you have control of, or administrative rights to. So you're going to need to install an IDE, which is a development environment for Python. It's free, so we're not asking you to buy anything. You just have to go to python.org and download the software, python.org. So if you go to python.org and download, you'll download the latest version of the IDE. It's called Idle. Don't need it now, but later you're going to need it. That should be on your computer, so that you can do the lab work. Okay, so there's that. Now notice about the labs. Man, all right, those, as I say, these are what are put to us. So you do need to get that lab done before the end of the lesson. Not allowed to share work. That's what plagiarism means. And yeah, so there's that. Now I did promise that I would talk about the textbook. There it is. It's not really a textbook. It's a suggested book. You don't need to buy it. But there it is. It's written by Carl Beecher, and it's called Computational Thinking. We don't use all the chapters in that book, but certainly the first 5-6 chapters fit in pretty good with our lecture topics, except for these first 2 lecture topics. First 2 lecture topics, history of computing and computing nowadays, they're not really found in that textbook. You know, it's just stuff that lecturers put together. So there's your textbook. Now this piece of paper here, it's not a piece of paper, is it? This document is on D2L, so it's always there for you to look at. So just again, if you want to look at that document at any time, just go to your content, and in your content, go to general, and there's a document there. And so you know, I can't remember what the textbook is. There it is, right? And there, and also you can look there and see when's the next test, when's the next lab. Yeah, okay, what's the next? We should be delivering it according to that schedule. So that document is useful to you. I hope that you sort of review it. Now, I'm not handing that out as a piece of paper to you. However, I will if you ask me to. The reason why I didn't is because I want you to look at D2L, because there's lots of stuff on there. I want everything to be in one place. But if somebody feels that they need to have it, I'll print it out for you. I've had in the past a student that had visual impairment, and so they couldn't see things that were small. And so, you know, we printed out things on A3 paper for them. You know, I mean, we will try and help people that need extra help. You know what I'm saying? So, I mean, if you feel for any reason that you need to have a piece of paper in your hand, I will produce it for you. Okay. So it's not that I'm just saying, oh, no, those students, they don't need paper. What I'm saying is, I don't know if you need it or not. If you tell me you need it, then you need it, and I'll get it for you. But if you don't tell me you need it, I'll assume that looking on D2L is good enough for you. All right. So for me, that would be good enough. I'd like it that way, because I mean, you don't even need to have your computer, right? You can open up the website on your phone, and you can look at the document there. So it's always with you as long as you've got some kind of Wi-Fi connection. You know, you have it. You can always look at it. Okay, so that's that. Going back into the content, the next sort of thing there is, let's start with our lecture. Should we do that? Any questions first? No? All right, so let's go. Electronic computing. Let's do the PDF one, because if I open up the PowerPoint one, it takes time to load. All right. What I think we're trying to show here is that we've had some mechanical devices computing. If we had a definition of computing, I think we would say that we've been using the word computing, and we've been using the idea of computing for a lot longer than we've had the electronic computer devices that we're using now. So this is an old idea. So maybe you could say that like an abacus would help people in doing a kind of computing. And so, in fact, if you went back 150 years ago to Europe, and you went to somebody's office who was trying to run a some kind of a business, they might have a person in the back room there who's adding up all the things people owe him money, that type of thing. They might have a person doing that. And the business owner might refer to that person as their computer. All right, so they didn't have a machine in the back there, they had a person that was doing computing. And in which case, computing was just calculating things. And so that was a computer, a person. And so, of course, they might have had some devices that helped them to do that. 3,000 years ago, this device was invented, and probably some of you have actually seen it. So people have been using this for a long time, the abacus. And if any of you have seen people use this, the people who are skilled in using it can do mathematical operations quite quickly on it, right? You see these guys, you know, they're just, you know, they're multiplying, dividing really, really quickly with this and adding things up with an abacus. This other device here is a little bit newer. It's only been around for a couple hundred years. It's called a slide ruler or slide rule. We're not using them anymore, and that's because they've been replaced by electronic calculators. Just like that person in the back room who used to add up everything for the business person has been sort of replaced by a computer, electronic one. So the slide rule was used. I used one, so it's not that old. I mean, I know I'm pretty old, but I'm not that old. When I was at high school, we used slide rules, and we used these little tables that were called log tables to do our mathematics, because when I was at high school, we didn't have slide rules. So we had slide rules. We didn't have calculators. And that's not because the school wouldn't let us have calculators. It's because there was no such thing as calculators, right? So that's back in the 1970s. And so we used a slide rule and a log tables to do our maths. It's kind of cool. But people have been thinking about using things like, so a slide rule is a mechanical device, I guess you could say. Something's moving, and we have some little notches on it to sort of do our calculations. Babbage in the 1930s developed a machine to actually do mathematical things on it, all right? And he wasn't the first one. You'll see that in these notes. There were people before him that made machines to do mathematics. And of course, the abacus, 1,000 years old, right? Hollerith was trying to solve a problem for the United States government, which they had a census. In the census, they needed to know how many people there were and where they were. And that was a big problem. And so actually in the 1800s, they would do a census every 10 years, like 1860, 1870, 1880, like that. And then it would take them 10 years to do all the calculations, right? So you do the census in 1870 and you wouldn't have all the results tabulated until 1880. So, you know, how useful is that information, right? I mean, it's better than nothing, but it could have been more useful if it was more timely. And so Hollerith was trying to solve that problem, and he came up with a way that we'll talk about. The transistor radio after the 1940s, that was a first step towards what I'd call miniaturization, making getting as much power but with less space, using less energy and less space to get a computer doing what a bigger, more energy consuming computer used to do. We had a transistor do that. Then the last picture there is of an Apple Mac, which was introduced in the middle of the 1980s. And it was the first computer that gave people a graphical user interface. So you notice that there's a mouse with it. So the first computer had a mouse and sort of, you know, you could move on the screen with a pointer. That didn't happen until like 1985. Did they have computers before 1985? Yes, we used to use them. I mean, when I started university in 1977, and the first year of university, I had to do a math course. You guys have to do a math course, right? So I had to do a math course, and in the math course, one of the sections was we had to write a computer program on the university's computer in 1977. Now, how that we used to use computer input cards, but it certainly didn't have anything like this, right? Didn't have anything like that. I'll show you some other things about that. So here's this word computing. It's about calculating. Computer science is new. It's a new science. There's people writing computer programs before there was a such thing called computer science, right? People just learned how to use computers. Various engineers, I guess, would do it. My first job in computing was in the 1980s, and I worked in a telephone company. And yeah, there was hardly anybody who had a computer science degree. They were just starting to get computer science degrees in Australia then. So like, I did a degree in commercial computing, but my first degree was in chemistry. Right, the guy sitting beside me had a degree in biochemistry, and then he did a degree in computer engineering. I mean, so when they introduced computing, they had to start from what they had, right? People that were around. So I worked with mathematicians, biochemists, biophysicists, astronomer worked with us. So all of these people that did all these, mostly some kind of science, and then learned how to use computers. So that was the way it is. But nowadays, of course, people go straight from high school and start learning how to do computer science, which is maybe saves a bit of time. The Abacus I've already spoken about, right? So it's been around for a long time. You may have seen one. Have you, any of you ever seen somebody use one? I mean, it's a pretty neat thing. I think somebody could teach you how to use it fairly quickly. But basically, it wouldn't be me who would show you how to use it. I'd have to have them show me how to use it first. I mean, you can do mathematics with it, and people used to keep their accounts with it. Apparently, there's a version of it that was developed and used in Afghanistan. That's not far from here, and some other places too. Of course, the Chinese used it. So then that's a long time ago. That's 3,000 years ago, apparently. Then there's this fellow by the name of Blaise Pascal, coming a bit more recent, but that's not that recent, like, right? That's, gee, 350 years ago, 360 years ago, Blaise Pascal, French dude. He was a mathematician. He was a mathematician slash philosopher. And in his spare time, I guess he played around and pretended to be an engineer. And so he made this machine that would do calculations. If you look at it, it had a lot of spinning dials and stuff like that, kind of like a watch. So a watch is kind of like a computer in a way, right? You know, the dials spin, you know, 60 seconds to a minute, 60 minutes. Yeah, I mean, so instead your dials would be 10 and then 100, you know, that kind of thing. But he had this machine that would do calculations. Something similar was this thing by Leibniz. Leibniz is German. So we got a French dude and a German guy at that time. You guys are doing math. You're going to have to do some calculus, right? Is that the course that you're doing? Calculus? Is it? I think so. So you might be interested that Leibniz is credited with inventing the calculus in Germany. Now, of course, somebody's going to say, no, it wasn't him. It was Isaac Newton. You're right. It was Isaac Newton. He wrote the first book about wrote the first book in English about calculus, but they're about the same time. Actually, Isaac Newton sort of invented the calculus in about 1670. And I like to tell this story because I think it's kind of a cool one. But in the late 1660s, there was a pandemic in England. All right, and they closed the university. And Isaac Newton was a young student, kind of like you guys. You know, I think he was about 20 years old, maybe younger than that. And they closed the university, so he couldn't go to classes. So what's he going to do? Is I think he had like 2 years off university, had to sort of sit at home, socially. What do you call that? Social distancing. So he's social distancing for 2 years. What does he do? He invents the calculus, right? Because he didn't have computer games, so he had to do something else. So he invented calculus. You guys like calculus? You're going to find out about it, right? Obviously, he's a pretty smart guy. Now, Jacquard's loom, why would we talk about Jacquard's loom in computing? Because Jacquard's loom had an input device, which was a card which had punch holes in it. And according to the punch holes, you could program the loom to make a different pattern in the whatever it is the loom was used. So you know what a loom does? It's going to make cloth or a carpet or something like that. And so Jacquard, a couple hundred years ago, was able to program it, and that would make it more efficient and work more quickly than just you know, people sort of reading a thing or memorizing a pattern and trying to do it. Now, some people who are really skilled could probably do it pretty fast, but Jacquard's loom, you could have this thing reproducible so that people with less skill could do it quickly as well. Charles Babbage tried to make, and did make, designed a machine which is like a big bunch of clocks together that could do mathematics, and he called it analytical engine, could do computing. It looked kind of like that. So you see a lot of gears. I'm not going to pretend that I know exactly how that worked, but I'm guessing that because we use a number system which is base 10, that we would have these gears that somehow relate to numbers 1 through 10. I bet if you counted those, it'd be like 10. And so you could do multiplication, division, subtraction, addition. Ada Lovelace, my understanding is that she was aware of these machines. And so she said, well, you know what we actually need to make those machines work is you need to have some kind of a step-by-step instructions for the machine. And so that would be kind of like what we would call a program. And so she sort of developed step-by-step instructions to work with these mechanical machines so that we could have something that we'd call like a computer program to solve problems. So that was Ada Lovelace, very smart lady. And right, that brings us to this fellow here, Herman Hollerith, who's trying to solve the problem for the United States government, which was their census in 1880. Too much data. He was aware of this. He was aware of this Jacquard's loom, and he was aware of the fact that we had a card, which by the holes in the card you could program the loom. And he's like, well, you know, maybe I could use something like that to gather the data from the census. And so he actually came up with a system where he could use holes punched in cards like that to gather information about the census. So the holes would line up to things like, you know, male, female, age, address, you know, so, and basically by the hole in there, we could gather all that information very quickly if you could read that somehow. Now, the picture of this young lady beside there is supposed to represent the input that would be done, right? So what she's doing is she's typing on a sort of machine or punching some lever somewhere. And based on that, this drum, I suppose, is making holes in some cards. And then the card is used to store the information from that particular thing, right? And then you'll read that later with some machine. Now, IBM sort of developed out of that. So there's a direct relationship between Hollerith and IBM. IBM sort of picked up Hollerith's idea, and IBM actually designed their own sort of multi-purpose or general purpose machine readable card that you could punch holes in it, right? And so there's different sections in the card and different meanings for each of the holes that you might punch in the card. So you could punch holes in the card, and that could relate to some instructions for the computer. So that was done by IBM, as it says here, from the 1920s, and that continued into the 1970s. A minute ago, I told you that when I first went to university, my first degree, I had to do a assignment, which was a Fortran program on the computer. And the computer was a mini computer. Actually, the computer was at another university. So we had a terminal at our university, and then our university had a phone line that went to the other university, and the calculations were done there. So we would make a deck of cards like this with our computer program on it, and then we'd put that at the input reader, which was at our university, and then we'd go and have a coffee or whatever, come back an hour later, and then they would get a result. And because of it, now the cards that we used were not like this. They were cards that we used a pencil to mark it, but otherwise similar to this. And you know, you'd write your little program on that by picking the right ones. So that was happening. As I said, my first year at university was 1977. I remember sitting in the computer lab in 1980, would it be? Yeah, maybe 79. And we didn't have to use the cards then, right? So we had terminals that we could type things in. And so we would use the computers to do calculations on linear regressions for the rates of reaction for chemical reactions, because I was doing a degree in chemistry. So a lot of people use computers, but back those days, yeah, who was using it? It was mostly big businesses or engineering or a little bit in science. But computers, I think, were first used in big way by government and big businesses, because they're very good use for them in that. And so government and big businesses would they'd have enough money to build things like this that would cost millions of bucks and take up a whole room in a big building and take a lot of power. And so, yeah, that's why it was first done by things like the United States government. But pretty soon, as I said, businesses. So nowadays, you're banking. A lot of people, I've seen them here when I go to have my lunch, right? People don't carry cash anymore, right? They just walk around with their card and they put their card on the thing. So how does that work? Well, I guess you could say the terminal where you tap your card, that's actually an input, which then it communicates with a computer somewhere. That's the bank's computer, and the bank's computer has records about you, how much money you got in your account. And then after you tap that, you got a little bit less money in your account. No cash, right? So nobody handles any cash. There's money in the bank that somebody put in there. Maybe you did. Maybe you got a job and that money is put in there by your boss, or not your boss, by the payments department in your company. Or maybe if you're not working yet, maybe your parents put money into an account for you. I do that with my 16-year-old daughter. I gave her a debit card, and like every week I just add some money to it, and that way she doesn't have to come begging me for money all the time. And so she just take her card, right? But what the point that I'm making is, you could probably go for a long time without handling any paper money or coin money, right? You just do that. You just use your card everywhere, right? And so how is that bank working? Everything is on the computer. There's a balance, which is like a database thing, kind of, with your name as an account number and numbers beside your name. And so that's all on computers. So banks are big users of computers. The other ones, I think telephone companies are big users of computers, of course. But nowadays, every business. But the reason I mentioned the bank is because it was pretty obvious to bank people that the computer would be a big use to them from a long time ago. Like in the 1950s, they started using computers. You know what I mean? So, when I was going to university, I supplemented my income by I didn't have much income. On the weekends, I used to drive a taxi, and the reason why I mentioned this is to do with the banks, because at 1 o'clock in the mornings, I drive on the weekends. 1 o'clock in the mornings, all the banks in Brisbane, Australia. I used to live in Brisbane, Australia. All the banks in Brisbane, Australia, they had one clearing center where there was a bunch of, they're mostly ladies, would work there until like 1 o'clock, 2 o'clock in the morning. What they were doing is all the checks that people had written, bank checks. Do you remember those? I don't know if people use them anymore, right? They use them a lot in the States. But yeah, back in Australia,